All right, what you want to do is you want to be able to recognize, again, the first step in all of these types of problems when you're dealing with the oblique non-right triangles is figure out what pattern of information is provided. We're given three sides here. So three sides tells you you're using the law of cosines. Remember, the rules are any of the patterns involving two angles are law of sine. So ASA and AAS, as well as the non-congruence pattern SSA. So those are the three patterns for the law of sines. Law of cosines has two patterns. They're the two patterns that involve two sides. So SSS and SAS. Okay. So the SSS pattern, you identify that you're using the law of cosines. And so since we know that our extremes, so that first and the last term in our law of cosines, one of those is going to contain the variable, the unknown. So here's our unknown angle. So we need to start with the side opposite that. So this determines which piece we start with. So we're going to set up as 10 squared. The side opposite the unknown squared is equal to the sum of the squares of the other two sides. And then the adjustment is minus 2 times the product of those two sides, all times the cosine of the angle x. Okay. So what we can do is we can use our calculators here to solve this. But remember, the way that we have it set up right here, our calculators can't identify an inverse trig ratio on its own. Okay, so what we have to do here is we have to use a substitution. And since x is already in my problem right here, I'm just going to say let y equal cosine of x. So I'm going to replace cosine of x with y, which means I'll have to tell the calculator to solve for y. So here's what I would enter. I'd access my solve feature under this F2 algebra tab, enter my equation. Again, I'm going to enter it exactly as it is. I'm not even going to do any mental calculations, even though these are relatively basic numbers, and you're probably familiar with them. Okay. It doesn't save a whole lot of time to calculate it mentally, so I'm just going to type it in exactly as it is. Okay. Tell it I'm solving for y. Okay. I didn't put any decimals in my entry, so I'm going to hit the green diamond button so I get a decimal display. And what am I expecting here? Again, I'm trying to encourage you to make a prediction. And what are you predicting? What should the value be between, since we're dealing with a cosine ratio? Right. Between -1 and 1. Okay, so let's see what happens when I hit enter. I get 0.625. So I'm going to plug that in. 0.625 is equal to cosine of x. So I'm substituting that in directly for y. Okay, it fits with what my prediction was. It's consistent at the very least. So now I'm going to take the inverse cosine of this. So I take green diamond, z gives me the inverse cosine. I can just highlight it. In this particular case, it is a terminating decimal, so you could just type in 0.625 if you want. If we didn't round it, that is the exact answer. And because we're not going to be doing anything else with this measure, I don't have to get rid of the y equals. I can just leave it there. If you want, you can get rid of it, but it's not going to affect anything. So I hit enter, and I get my angle measure to be, so x itself is going to be the inverse cosine of that ratio, which I entered in. And so I get x to be 51.3.